Okay, so today we are doing a medium problem design browser history. A browser of one tab where you start on homepage. You can visit another URL, get back in the history number of steps, or move forward in the history number of steps. So I have to implement this class, which takes homepage of the browser. Visit clears up all the forward history. Okay, so I think that means if you did some browsing, then you went back a few steps and then you visit, then it clears the previous ones. If you can only so back is x steps. If you can only x is lazy or return only x, return the current URL after moving back in history at most steps and forward at most. Let's see an example. So you create with homepage, from Leetcode to Google, from Google to Facebook, from Facebook to YouTube, then you go back to Facebook, back to Google, Facebook, you visit LinkedIn, which kills off YouTube. So if you go forward, that only goes to LinkedIn, and then you go back to Google, I think. Yeah, that's true. Okay. Then go back 7. You can only return to Leetcode, which is your home page. And that's. So I think I just need a. Maybe double linked list. I think that should be easy. So let's make a private class. Let's do the class here. So our struct whatever. So struct node, which takes in the string page, and then it takes node previous and next. Okay. So for initial home page, we say that let's do something private node root. Let's do like node. So this node, new node, should take some constructor. So node. I guess I can actually skip it. New node, home page, null pointer. Okay, so this means that we visit. So what that means is that we erase the forward history. Okay, so we do node next is new node which has URL, then its previous node is this node, and next one there is none, and then this node and its next is equal to next, and then this node is equal to this node next. Now to go back, what we do well, while this node previous, we go for int I 0 I steps, and this node previous I plus, and what we do is this node equals this node previous. Okay, and same for forward. So for int I is under steps, so we try to do these steps, but we also have to have a next element, this node, next, and that should suffice, I think. Compilation error, because I will figure it out. I'm not returning anything. Return this node page, and also return page here. Okay, so that was a simple, quite literal 5-minute exercise in doubly linked list. Doubly linked. Okay, so linked list. Store history as a linked list with pointers to next and previous page. When going forward/backward, simply go forward/backward in the network, in the list. When visiting a page, remove the next node, create a new node for the new page, and make it the new next pointer in the current node. Time complexity O of 1 for visit and O of n for forward/backward operations, since where n is the number of steps / okay, we will do steps, but it's gonna be linear to steps, so I mean we are linear to let's call it m, where n is the number. Let's do new nm. In the query, and m is the number of pages. Space complexity is O1 for the linked for the current node in the linked list. Okay. I'm not sure if that's correct, so let's check the editorial. Oh, 2 stacks. That's smart, but that's slow also. I think doubly linked list. Okay. Yeah, algorithm, blah blah blah, what the time complexity O1 and OL. It will take what OL time to allocate memory for L characters? What the hell? Okay. Dynamic array. I mean, you can, but why would you do that? Why would you do that though? Interesting approach. Yeah, this was what I thought, that it leaks memory, but yeah, well then operations are slow, but then all operations are slow. Technically then the approach 3 is the fastest, which is interesting, because yeah, this is actually the fastest. Okay, fair enough. I thought about the leaking of memory, because it's not really O1. Can I edit somehow? All solutions, my solution. I would like to edit it, but that's terrible if okay, I can edit. So the memory is ON for where N is the maximum number of pages. Restore. Okay. Note that when visiting we have to erase the to avoid memory leaks. We have to delete all previous all forward history notes which takes O in worst case. But we only have to delete O1, I think it's O1 amortized for visit, since worst case it takes ON. We are at the start of the history, but we would have to first visit those n elements, so the work is evenly distributed between the previous visit calls. For forward/backward operation, the time complexity is whatever, where blah blah. O1 amortized for visits in worst case, since worst case it takes, since in the worst case worst case it takes on. We are when we are at the start of the history, but we would have to first visit those on elements, so the work is evenly distributed between the previous visit calls. For backward operations, time complexity is O min m, where m is the number of steps in the query and n is the number of pages. Space complexity On, where n is the maximum number of pages we store. Fair enough. Update. Okay. I wanted to do medium problems sometimes to get practice, but so far there was one problem I couldn't solve in these, 7 days is it? Okay, see you tomorrow, bye.